Hey everybody, Mr. Piercy here. What we're going to be looking at today are how we describe angle pairs, meaning can you well, it's not so much a description because I'm not going to be asking you to say what does it look like, but more can you identify what angle pairs are by looking at a diagram? If I tell you the vocabulary term, do you know what they mean so you can set up and solve an equation to find the measurements of the angles and so on? Now, some of the vocabulary that you see here is probably some of that tip of the iceberg material that you know already. Complementary and supplementary angles, nearly every math student that I have come into high school geometry knows what those words are beforehand. There's a mixture of students that know what adjacent angles are, meaning that they're just two angles that share a side. The linear pair adjacent angles whose non-common sides form a straight line because they're opposite rays. Linear pairs are usually the most commonly drawn example of what supplementary line or supplementary angles are. Vertical angles are probably the newest one. Now I want you to kind of pay attention to the diagrams here that we have on the side. The first pair of angles up at the top are two examples of what complementary angles are. Uh, Most people think complementary angles have to be adjacent. Same thing with supplementary. They think those angles have to be adjacent also, but they don't. They're simply two angles that make uh, 180 or 90 for supplementary or complementary. Adjacent angles are going to be something where we kind of share a side between the two angles that we have. Linear pairs are almost exclusively what's drawn for supplementary angles, because you can see we have a straight line between them. Now the new one, or the one I believe is probably the newest to you, are the vertical angles. Vertical angles are angles whose pairs of sides form opposite rays. So here we have an angle X, and here we have an angle X. Those would be classified as opposite angles to each other, or vertical angles to each other. We often call them opposite angles because what we would use to name the angle sometimes, like X, or like I could say this is 1, and this is 2, we would often say that they're on opposite sides of the vertex. So I could say like this angle here is 3, this angle here is 4. Now one of the things that I kind of want to point out on the vertical angles is, if you notice, it's telling you vertical angles are always equal to each other. So let's just kind of walk through why. Let's just say that the measurement of angle 1 is 130 degrees. Well, if the measurement of angle 1 is 130 degrees, angle 1 and angle 4 are a linear pair, therefore they have to be supplementary. So if angle 1 is 130, then that means that angle 4 has to be 50 degrees. Well, same thing with angle 1 and angle 3. Those are a linear pair and therefore supplementary, so this would also be 50 degrees, and you can see that angle 3 and angle 4 have the same angle measurement. Well, continuing on, angle 3 and angle 2 form a linear pair and therefore supplementary, so that means angle 2 has to be 130 degrees. So vertical angles or opposite angles are always going to be congruent to each other because they'll have the same angle measurement. Moving on here, we're going to take a look at, can we identify complementary and supplementary angles? Now, specifically, let's look at complementary angles first. Complementary angles are simply two angles that have a sum of 90 degrees. So looking at the diagram, I can see I have a 52 degree angle here, and I have a 38 degree angle here. So between angle ABD and angle CDB, those are two angles that make 100 or make 90 degrees, and therefore they are going to be complementary. Now, let's take a look at something that would be supplementary. So supplementary are two angles that have to have a sum of 180 degrees. So here I have angle ABD, and here I have angle DBA. Those two angles, oops, I'm going backwards. I'm saying the same angle twice. What I meant to do was show angle BDE. Between those two angles, the 52 and the 128, they have a sum of 180 degrees. Therefore, those two angles are going to be supplementary to each other. And lastly, we're looking for something that has sides that are shared between the angles. And if I'm looking here, let me go ahead and clear this up. Get rid of that ketchup and mustard looking thing that I had going on. Let's go ahead and look here. Here, we're looking for angles that have a side in common. So here I have this angle, angle BDC, and then I have this angle EDB. Well, they share this side right here, and they share the vertex here at point D. So that means those angles would be something that we can classify as adjacent angles. So moving on, here we're looking at finding the measurements of complementary and or supplementary angles. Now, these are very commonly, very common types of questions that we see, but for us, we're starting it off very basic as far as saying, well, we're actually using angle measurements as opposed to an algebraic expression, but we'll get to those in a little bit. Now, when I read the question, we see that angle 1 is a complement of angle 2. That is a clear indication that we're talking about angles that have a sum of 90 degrees. Now, the way that I would personally set that one up, here we're talking about figure A, or problem A. The way that I would set that up personally is I would say the measurement of angle 1 plus the measurement of angle 2 has to equal 90 degrees. And since I'm looking for the measurement of angle 1, I can say that the measurement of angle 1 must be equal to 90 degrees minus whatever the measurement of angle 2 happens to be. So I would say the measurement of angle 1 would be equal to 90 minus 57 degrees. And in the notes that we have here, they're kind of jumping the gun a little bit, in my opinion. I like to think, most people tend to think two angles that are going to make 90 degrees, so that's how they think of complementary angles. We don't always think the difference of 90 and another angle are complementary angles, and that's how the example is kind of setting it up by saying they're jumping right to the fact that the measurement of angle 1 is going to be whatever 90 degrees subtracted from, or when I take away the measurement of angle 2 from it. Moving on to part B. Well, part B here, it says, given that angle 3 is a supplement of angle 4. So right away, just by seeing that word, we need to recognize we're talking about angles that have a sum of 180 degrees. And again, the way that I would kind of work problem B out is I would say the measurement of angle 3 plus the measurement of angle 4 has to be 180 degrees. Well, since I'm looking for the measurement of angle 3, now I can move angle 4 over through subtraction. Oops. I said angle 4 and I wrote it when I meant to write angle 3. Since I'm looking for the measurement of angle 3, I can say, well, that has to equal whatever 180 degrees minus the measurement of angle 4. And then I would substitute my numbers. And so this one was 41 degrees. So that's really how I'm going to kind of set that one up. And then we're going to just jump in here, and I have a typo on my paper, or on my thing here. This is supposed to say the measurement of angle 4, not 41 degrees. So they're just kind of jumping one step ahead of me, because I, again, like to think of complementary supplementary angles are two angles that are going to add up to equal something, not something where I'm going to say 90 minus something or 180 minus something. So hopefully you get the picture, but if you have any questions, by all means, let me know. Now at this point, I want you to go ahead and pause the video, answer the following 3 questions, and when you're done, go ahead and hit play and kind of compare your answers against mine, see how you do. So go ahead and pause the video now and answer these questions. Alright, so I'm assuming that we have some good answers here, and when we are looking at identifying the complementary, supplementary, or adjacent angles in the diagram, here I was able to identify complementary angles as angle DEF and angle B because they have a sum of 90. Angle FEG and angle B are supplementary because they have a sum of 180. And DEF and FEG would be adjacent angles because they share a side and a vertex. Here we're looking at angle 1 as being a complement of angle 2. So again, they're going to be complementary and they have to add up to be 90. So I say angle 1 plus angle 2 equals 90. Move angle 1 over through subtraction. Substitute my numbers, and angle 2 is 17 degrees. Same thing with here, angle 3 and angle 4 being supplementary. I'm going to say those two angles make 180. Move the angle 4 over through subtraction. Substitute my numbers and say angle 3 has a measurement of 143 degrees. Now here is where we're going to really get into the types of problems that we really think of, or that I really think of as the instructor, as far as, do you really understand how to identify the angle pairs that you see, set up an equation based off of that, and then find, say, the measurements of the angles or something. Now here they're telling us in the diagram that the basketball pole forms supplementary angles with the ground. Well, that means that the two angles that we see, angle BCA and angle DCA, those have to add up to be 180 degrees. So the way I set up my equation is I say BCA plus DCA has to equal 180 because those are the two supplementary angles. Substituting the expressions that we have that were given to us by the problem, we get 3x plus 8 plus 4x minus 3 equals 180. Now the parentheses aren't really necessary because all we would do to get rid of the parentheses would be to distribute a positive 1. So we can just go ahead and combine our like terms. The 3x and the 4x give me 7x, and the 8 and the 3 give me a 5. Then I'm going to move the 5 over through subtraction and then divide by 7 and show that x in this case is going to equal 25. Well, now that I know that x is 25, I can go back to their respective expressions and substitute the number 25 and find that the measurement of angle BCA is 83 degrees and DCA is 97 degrees. Keeping in mind that my final answer, these two, really better add up to be 180 degrees. If they don't, we made a mistake somewhere. So now moving on, here is another example, very similar to what we did before. We're still looking at the diagram in example 3, but the expressions that we have are different, therefore the measurements of our angles will probably be different. So go ahead and pause the video, work out problem number 4. When you have your answer, come back and compare your work with mine and see how you do. Alright, so hopefully we have a good answer here for the measurements of our two angles. Now I'm going to set this up the exact same way that our previous example did, where I'm going to say the measurement of the two angles have a sum of 180 degrees. I'm going to substitute the expressions, combine my like terms, and isolate my variable, and in this case x is equal to 16. Substituting 16 into the expressions that we have for our angles, I'm going to find that the measurement of angle BCA is 81 degrees and that the measurement of angle DCA is 99 degrees. And again, the sum of my two angles should add up to be 180 degrees. If they don't, I made a mistake somewhere and I have to go back and check my work. So here is a really good example of making sure that can you identify angle pairs correctly, because you have to be able to identify what an angle pair looks like, or you have to be able to identify an angle pair in a diagram based on what its definition tells you it should look like. So here we want to identify linear pairs and vertical angles. Now linear pairs and vertical angles are particularly useful whenever we're trying to figure out measurements of different angles in a figure when we only know certain angles to start with. So looking at the vertical angles first, find the vertical angles. Vertical angles, again, they're kind of made with lines that intersect each other. So 1 and 2 are vertical angles, 3 and 4 are vertical angles. And of course the vertical angles are congruent to each other. Well, looking for examples that we see that look like that in the diagram that we have, vertical angles we're going to be looking at in this case would be angle 1 and angle 3. And those are the only real pair of vertical angles that we see here. To find a linear pair, now we're going to be looking at something has to make a straight line with when I have two angles that share a side and a vertex. So looking at the diagram, I can see right here I have a line, And here I have a side that's shared between angle 1 and angle 2. So those form a linear pair. Now I can also look and see that angle 2 and angle 3 form a line and they share that side. So that means angle 2 and angle 3 are also a linear pair. And those are what we're looking at to try and identify what our angle pairs are in the diagram that we see. So here's the exact same kind of question with a different diagram. Pause the video, identify all of the linear pairs that you can and all of the vertical angle pairs that you can, and when you're done, hit play and see how your answers look against mine. Alright, so hopefully we have a good answer here, or a couple of answers I should say, since we're identifying more than one type of angle pair. Now in this case, remember, linear pairs are going to, in some way, make a line that have a side that's shared between two angles. Now we have several lines here, and a common answer that is given to me in class is that angle 3 and angle 4 would be angle 1 and angle 3 would be a linear pair, because, well, we do have this side of part 3 and this side of part 1 that are making a straight line. The problem is that they are not adjacent to each other. They do not share a side and a vertex. So when I look at the rest of the diagram, I can't find any examples of linear pairs in the diagram. Now vertical angles are angles that are opposite of the vertex. So angle 1 and angle 4 are an angle pair, 2 and 5 are an angle pair, and 3 and 6 are also an angle pair. So there are 3 different pairs of vertical angles, but no examples of linear pairs in this particular diagram. Now here we're coming towards the end of our examples. This is a particular favorite type of problem of mine, because it separates the idea of the fact that it still works on the idea that we're using algebraic expressions to work with our geometry stuff. However, it's not simply saying, here's an angle expression, here's an angle expression, write an equation and solve it. We have to use a little bit of reasoning here. So it says two angles form a linear pair, meaning that they're supplementary. And it's always useful to draw a diagram if you don't have one given to you. Well, one angle, since we don't know it, we just call it angle X. The other angle, based on what it's telling us in the diagram, has to be 4 times bigger. So I'm going to just say 4 and multiply it to X and say that the other angle is 4X. Well, linear pairs are supplementary, so I'm going to say angle X, or the angle that's X degrees, and the angle that's 4X degrees have to have a sum of 180. Combining my like terms and dividing by 5 says that X is equal to 36. So the measurement of one angle is already 36 degrees. To find the other measurement, multiply it by 4, and we see that it is 144 degrees. And again, the 36 and the 144 should add up to be 180. Otherwise, we made a mistake somewhere. Here's the last example that you guys are going to work out on your own. So go ahead and pause the video at this point. Answer question 6, very similar to what we just did on the last example. And when you're done, go ahead and hit play and look how your answers look against mine. Okay, so I'm going to assume that we have our final answer here. I have two angles. One of the angles, I have no idea what it is, so I call it X. The other angle has to be 3 times that, so I call it 3X. Then I say the two angles make 180. Solving for X in this case gives me 45. Finding the measurements of the missing angles, in this case, one angle has to be 45 degrees because it's just X. The other angle is 3 times that, so 3 times 45 gives me 135 degrees. So here is kind of where we're going to stop as far as talking about, the relationships of the angles and how we identify them in diagrams, and based on what type of angle pair that we have, how we set up and solve an equation based off of that information. And if you have any questions about anything that you've seen in the video, by all means let me know what those questions are. I'll be happy to help you out. And until next time, guys, thanks for watching and take care.